I, Dr. R. Mangayarkarasi, Assistant Professor, EMG Yadava Women's College, Madurai 14. ஸோ நம்ம இன்னைக்கு கிளாஸ்ல என்ன பார்க்க போறோம்னா நியூமரிக்கல் டிஃபரன்சியேஷன், இன்டகிரேஷன் அண்ட் சொல்யூஷன் ஆஃப் சம் டிஃபரன்ஷியல் ஈக்குவேஷன். இந்த பிளாக் இன்ட்ரோடக்ஷன், நோட்டேஷன் அண்ட் சிம்பிள் யூனிட் 12 நம்ம ஆல்ரெடி பார்த்துட்டோம். லாஸ்ட் செஷன்ல நியூமரிக்கல் டிஃபரன்சியேஷன் பார்த்துட்டோம். ஸோ இந்த செஷன்ல நம்ம என்னென்ன கான்சன்ட்ரேட் பண்ண போறோம்னா numerical integration and numerical solution of ordinary differential equation and numerical solution of differential equation using Ranch-Kutta methods. So இந்த ப்ரோக்ராம் தான் நம்மளுடைய இந்த ப்ரோக்ராம்க்கு இது வந்து லாஸ்ட் செஷன். நமக்கு in unit 3, unit 13ல நம்ம என்ன பார்க்க போறோம்னா we shall derive few numerical integration method, namely the method using Lagrange interpolation and method using Newton's forward interpolation. We shall also discuss composite rules of integration to obtain more accurate results and improve the order of the result using Romberg integration in the unit. In unit 14, we begin with the recall of few basic concepts from the theory of differential equation. We shall then derive numerical methods for solving differential equation. We shall introduce here two such methods, namely Euler's method and Taylor series method, to obtain the numerical solution of ordinary differential equation. We shall also introduce Richardson's extrapolation method to obtain higher order solution to ordinary differential equation using lower order method. In unit 15, which is the last unit of this block and also of this course, we shall discuss Ranch-Kutta method of second, third and fourth order for obtaining the solution of ordinary differential equation. We shall discuss Richardson's extrapolation method to extrapolate the solution obtained by the Ranch-Kutta method also. Now numerical integration 13.1ல வந்து நம்ம என்ன பார்க்க போறோம்னா introduction and objectives, and then 13.2 methods based on interpolation, method using Lagrange interpolation, method using Newton's forward interpolation. 13.3 composite integration, 13.4 Romberg integration, and then summary, some exercise problem having solution and answers. Now objectives. இந்த யூனிட் படிக்கிறதுனால நம்ம என்ன அவுட்கம் கிடைக்குதுன்னா, after reading this unit you should be able to use trapezoidal and Simpson's rule of integration to integrate functions given in the form of table and find the error in this rule. First வந்து ரெண்டு ரூல் நம்ம யூஸ் பண்ண போறோம், trapezoidal rule and Simpson rule for integrate function integrate பண்றோம். அந்த function வந்து given in the form of எந்த ஃபார்ம்ல இருக்கு, டேபிள்ல இருக்கு. And then லாஸ்டா நம்ம என்ன கண்டுபிடிக்க போறோம்னா error for this given function. Second one, improve the order of the result using Romberg integration or its accuracy by composite rules of integration. அதனுடைய ஆர்டரை நம்ம என்ன பண்ண போறோம், இம்ப்ரூவ் பண்ண போறோம். எது மூலமான? using Romberg integration. And then method based on interpolation. In block 3, you have studied several interpolation formulas which fit the given data xk, fk, k equal to 0 to n. இந்த மாதிரி xk, fk வந்து நம்ம நிறைய இன்டர்போலேஷன் ஃபார்முலா வந்து பிளாக் 3லயே நம்ம யூஸ் பண்ணிட்டோம். We shall now see how these interpolation formulas can be used to develop numerical integration methods for evaluating the definite integral of a function which is given in a tabular form. The problem of numerical integration is to approximate the definite integral as a linear combination of the values of f of x. In the formula integral a to b f of x dx equal to sigma k equal to 0 to n beta k fk, where the n plus 1 distinct points xk k equal to 0 to n are called the nodes or abscissa, which divide the interval into n subinterval. The closed interval வந்து n subinterval நம்ம divide பண்ண போறோம். Namely, AB divide as in the form of x0 less than x1 etc. In ascending order, we are dividing the interval AB. And BK k equal to 0 to n are called weight of the integration rule or quadrature formula. We shall denote the exact value of the definite integral by I and denote the rule of integration by I h of f is equal to sigma k equal to 0 to n beta k fk, where the n plus 1 distinct points xk k equal to 0 to n are called the nodes which divide the interval ab into n subinterval, and beta k are the weight of this function. Now the error approximating of the integral I by I h of f is given by E h of f is equal to integral a to b f of x dx, that is minus sigma k equal to 0 to n beta k fk. Here beta denote the weight of the given function. The order of the integrating method 3 is defined as follows. The equation 3 இருக்குல, அதுக்கு என்ன order? I h of f sigma k equal to 0 to n beta k fk. Definition: in integration method of the form 3 is said to be of order p if it produces exact results of the polynomial of degree less than or equal to p. Polynomial ஓட டிகிரி வந்து either equal to p இருக்கணும் அல்லது less than இருக்கணும். அப்படி இருந்தால் தான் அதை வந்து நம்ம என்ன சொல்கிறோம், இட் இஸ் இன்டகிரேட்டிங் மெத்தட் இஸ் இன் த ஃபார்ம் ஆஃப் ஆர்டர் பி. இன் ஈக்குவேஷன் 3 we have 2n plus 2 unknown, that is n plus 1 nodes xk and the n plus 1 weight beta k. Therefore n plus 1 n plus 1 if you are adding, that is 2n plus 2 unknowns. அதில் 2n plus 2 unknownsல n plus 1 வந்து நோட்ஸாக இருக்கு, இன்னும் மீதி n plus 1 என்ன இருக்கு, அது கரஸ்பாண்டிங்காக வெயிட்டாக இருக்கு. இப்போ இது ரெண்டையும் ஆட் பண்ணும்போது நமக்கு என்ன கிடைக்குது, 2n plus 2. And the method can be made exact for polynomials of degree less than or equal to 2n plus 1. 2n plus 2 is automatically less than or equal to 2n plus 1. Therefore, the method of the form 3 can be maximum order 2n plus 1. But if some of the nodes are prescribed in advance, then the order will be reduced. First, என்ன சொல்றோம்னா, இந்த ஈக்குவேஷன் 3ல பார்த்தீங்கன்னா சிக்மா k equal to 0 to n beta k fk. ஈச் வெயிட்லையும் n plus 1 எலிமெண்ட்ஸ் இருக்கு, fkலையும் நமக்கு n plus 1 எலிமெண்ட்ஸ் இருக்கு. இந்த ஃபங்க்ஷனோட ஆர்டர் பார்க்கணும்னா ஆர்டர் p produces exact result of all polynomial of degree less than அல்லது equal to p இருக்கும். ஈக்குவேஷன் 3ல எத்தனை அன்னோன்ஸ் இருக்கு, 2n plus 2 அன்னோன்ஸ் இருக்கு. அதில் n plus 1 நோட்ஸாக இருக்கு, n plus 1 வெயிட்ஸாக இருக்கு. அந்த மெத்தட் கேன் பி மேட் எக்ஸாக்ட் ஃபார் பாலினாமியல் ஆஃப் டிகிரி. இந்த மெத்தட் வந்து எக்ஸாக்ட் எந்த பாலினாமியல் டிகிரி லெஸ் than or equal to 2n plus 1 இருக்கணும். Hence the method of the form 3 can be maximum order 2n plus 1. But if the sum of the nodes are prescribed in advance, some of the nodes வந்து அட்வான்ஸ் நம்ம ப்ரிஸ்கிரைப் பண்ணிடும், then the அப்படி இருந்தால் ஆர்டர் வந்து ரெடியூஸ் ஆகிடும். If all the n plus 1 nodes are prescribed, எல்லா n plus 1 நம்ம ப்ரிஸ்கிரைப் பண்ணோம்னா, then we have to determine only எத்தனை weights இருக்கும், only n plus 1 weights, and the corresponding method will be maximum order n. Now method using Lagrange interpolation. Suppose we are given n plus 1 abscissors x case and the corresponding value f case. We know that the unique Lagrange interpolating polynomial Pn of x of degree less than or equal to n is given by f of x approximate to Pn of x, that is equal to sigma k equal to 0 to n Lk of x fk. With the error of interpolation, ஒவ்வொரு ஃபங்க்ஷனுமே நம்ம எரர் பண்ணுவோம். அந்த எரர் என்னன்னா en plus 1 of Pn of x is equal to pi of x by n plus 1 factorial f power n plus 1 of alpha, where alpha lies between x0 to xn, where Lk of x will be defined like that, x minus x0, x minus x1. in நம்ம Lagrange interpolation formula மாதிரி இந்த Lk நம்ம டிஃபைன் பண்றோம். And pi of x is equal to the corresponding factors, x minus x0, x minus x1, etc., x minus xn. We replace the function f of x in the definite integral 2 by the Lagrange interpolating polynomial Pn of x. This I h of f is equal to integral a to b Pn of x dx. That's sigma k equal to 0 to n integral a to b Pn of x is equal to Lk of x into f of k. That is sigma k equal to 0 to n beta k fk, where beta k is the weight of the given function, is defined as integral a to b Lk of x into dx. Now the error of the integration rule, the error will be en of f, that is equal to integral a to b en plus 1 Pn of x into dx. That is equal to integral a to b pi of x by n plus 1 factorial into f power n plus 1 of alpha into dx. We have modulus en of f is less than or equal to mn plus 1 by n plus 1 of factorial integral a to b modulus pi of x into dx, where mn plus 1 equal to maximum x0 less than xn modulus f power n plus 1 of x. Now let us consider now the case when the nodes x case are eq spaced, so equal space இருக்கு, with x0 equal to a and xn equal to b, and the length of each sub interval length எப்படி இருக்கும்னா h is equal to b minus a by n. A and b are the given interval, n வந்து number of values. The numerical integration method given by this 7. What is the seventh equation? That is I h of f is equal to sigma k equal to 0 to n beta k fk. So in the equation level known as Newton Cotes formulas, and the weights beta k is given by 8 in 8. What is that 8th equation? Beta k equal to integral a to b Lk of x into dx. This beta k is known as Cotes numbers, and the corresponding 7 will be Newton Cotes formulas. So any point x belongs to the closed interval ab can be written as x is equal to x0 plus sh. With the substitution, we have pi of x is equal to h power n plus 1 s into s minus 1 into s minus 2 s minus 3 etc. s minus n, and Lk of x is equal to minus 1 the whole power n minus k s into s minus 1 etc. s minus k plus 1, and then s minus k minus 1 etc. s minus n divided by k factorial into n minus k factorial. இதெல்லாம் வந்து நமக்கு ப்ரிலிமினரி ஃபார்முலாஸ் தான். அப்போ நம்ம ப்ராப்ளம் செய்யும் போது இந்த ஃபார்முலாஸ் எல்லாம் நம்ம அப்ளை பண்ணுவோம். Using x is equal to x naught plus x dash and changing the variable of integration from x to x, we obtained beta k is equal to minus 1 the whole power n minus k divided by k factorial into n minus k factorial h into integral 0 to n s into s minus 1 into s minus 2 etc. s minus n into ds and modulus e n of f is less than or equal to h power n plus 2 m n plus 1 divided by n plus 1 factorial integral a to b s into s minus 1 etc. s minus n into ds. We now derive some of the Newton Cotes formulas like trapezoidal rule, Simpson rule by using the first and second degree Lagrange polynomial with equally spaced nodes. You might have studied some of the rules, that is trapezoidal rule. When n equal to 1, x not equal to a, x n equal, that is the interval, h is equal to b minus a. Now using the equation 12 in that is like quotes, that is quotes numbers can be found as beta naught equal to minus h into integral 0 to 1 s minus 1 into dx. That is after integrating this value will be equal to h by 2. And beta 1 is also h into integral 0 to 1 s ds. This is also equal to h by 2. Now substituting the values of beta naught and beta 1 in this equation number 7. That is sigma k equal to 0 to n beta k f k. This summation runs over the values of k க்கு first 0 போடுங்க beta naught f naught plus beta 1 f1 plus beta 2 f2 like that. Therefore, we substitute the value beta naught beta 1 in this it of f is equal to h by 2 into f naught plus f1. So the error of integration modulus et of f is less than or equal to h cube by 2 m2 integral 0 to 1 s into s minus 1 into ds, that is equal to minus h cube by 12 into m2, where m2 is the maximum of modulus f double dash of x. Now by trapezoidal rule, integral a to b f of x dx is given by I of f is equal to h by 2 into f naught plus f1 minus h cube by 12 into m2. Now when f of x is a function of with positive values, then h by 2 into f naught plus f1 is the area of the trapezium. Height வந்து என்ன வருது, h is equal to b minus a, parallel sides are f naught and f1. This is an approximation of to the actual area under the curve y equal to f of x about the x-axis bounded by the ordinate x is equal to x naught and x equal to x1. Since the error given in this equation 15, error given in this equation minus h cube by 12 into m2 is contains a second derivative, trapezoidal rule integrates exactly polynomials of degree less than or equal to 1. These are all the necessary algorithm we are going to follow in this unit. Now example 1. Find the approximate value of I equal to integral 0 to 1 dx by 1 plus x using trapezoidal rule and obtain the bound of the for the error. The exact value in equal to log 2. Log 2 equal to 0.693147, correct to 6 decimal places. Now we are going to find approximate value for the given integral. Here in the limit in the interval will be 0, 1. That is x naught equal to 0, x1 equal to 1. H is equal to b minus a, that is equal to 1 minus 0, that is equal to 1. Now equation 14. What is that equation 14? It of f is equal to h by 2 into f naught plus f1. So h by 2 will be 1 by 2 f naught plus f1, that is equal to 1 plus half, that is equal to 0.75. So actual error equal to, given the I equal to some value, exact value, minus the calculated value, that is 0.75 minus the given log value, that is equal to 0.056853. The error in the trapezoidal rule is given by modulus et of f. This is less than or equal to half, that is equal to maximum of 0 less than or equal to x less than or equal to 1, modulus of 2 by 1 plus x the whole cube, that is equal to 1 by 6. 1 by 6 value will be this. Therefore, the error bound obtained is much greater than the actual error. So in this way, we are going to find an approximate value for the given integral. எது மூலமா, trapezoidal rule மூலமா obtain the error bounded னு கண்டுபிடிக்கிறோம். Exact value அவன் கொடுத்துட்டு I equal to log 2. This is correct to 6 decimal places. Next one, Simpson's rule. Simpson's rule for n equal to 2, we have h is equal to b minus a by 2, x naught equal to a, x1 equal to a plus b by 2, and x2 equal to b. Now from 12, what is that equation of 12? 12 gives beta k equal to minus 1 whole power n minus k divided by k factorial into n minus k factorial h into integral 0 to n s into s minus 1 etc. s minus n into ds. Now in this equation 12, we are going to substitute a value, that is quotes number beta naught equal to h by 2 into integral 0 to 2 s minus 1 into s minus 2 into ds, that is equal to h by 3, and beta 1 equal to h into integral 0 to 2 s into s minus 2 into ds, that is equal to 4h by 3, and beta 2, that is equal to h by 3. Now substitute all those values in equation 7. What is that? Again, I will repeat that equation number 7, that is sigma k equal to 0 to n beta k f k. So we substitute all the three values in this equation 7. It reduces to h by 3 will be common being outside. First term will be f0 and then f1, 4f1 plus f2. Now equation 17 is the Simpson's rule for approximating I equal to integral a to b f of x dx. The magnitude of the error of integration is given by modulus es of f less than or equal to h power 4 m3 by 3 factorial integral 0 to 2 s modulus of s into s minus 1 into s minus 2 into ds. That is equal to h power 4 m3 divided by 3 factorial integral 0 to 1 s into s minus 1 s minus 2. So we are splitting this integral 0 to 2 can be split as a two component. One is integral 0 to 1, இன்னொன்று என்ன இருக்கு 1 to 2. அப்போ தனித்தனியாக இது ரெண்டு இன்டெகிரலை இன்டெகிரேட் பண்ணி we substitute the limit value, we bring this equation will be equivalent to 0. This indicates that Simpson's rule integrate polynomials of degree 3 also exactly. Hence we have to write the error expression for 13. 13 equation will be, this is the equation number 13. That is modulus en of f less than or equal to h power n plus 2 m n plus 1 divided by n plus 1 factorial integral a to b s into s minus 1 into s minus 2 etc. s minus n into ds. So இந்த equation number 13ல கொண்டு வந்து நம்ம substitute பண்ண போறோம். அப்படி substitute பண்ணும்போது என்ன கிடைக்குதுன்னு பாருங்க. So 13 with n equal to 3. அப்போ modulus es of f is less than or equal to h power 5 m4 by 24 integral 0 to 2 s into s minus 1 into s minus 2 into s minus 3 into ds. Again we are splitting this integral. அப்போ நம்ம இன்டெகிரேட்டை வந்து ஈஸியாக பண்ணிடலாம். அதுக்காக நம்ம என்ன பண்ணுறோம், 0 to 2 வந்து ரெண்டு இன்டெகிரலாக ஸ்ப்ளிட் பண்ணுறோம். ஒன்று வந்து 0 to 1, இன்னொன்று வந்து என்ன இருக்கு 1 to 2. ஸோ அப்போ என்ன கிடைக்கும், minus h power 5 m4 by 90, where m4 equal to maximum of the modulus of fourth derivative. Fourth derivative ஓட maximum தான் நமக்கு m4. Since a error in Simpson's rule contains a fourth derivative, Simpson's rule integrate exactly all polynomial of degree less than or equal to 3. Therefore, by Simpson's rule, integral a to b f of x dx is given by I of f is equal to h by 3 into f0 plus 4 f1 plus f2 minus h power 5 by 90 into m4. Now, geometrically, what is that value represented? நம்ம அடுத்து பார்க்க போறோம். Geometrically, h by 3 into f0 plus 4 f1 plus f2 represents the area bounded by the quadratic curve passing through என்ன interval x0 f0, x1 f1 and x2 f2 above the x-axis and lying between the ordinates. இந்த லைனுக்கு நடுவில் இருக்கும்னா x equal to x0 and x equal to x2. In case we are given only one tabulated value in the interval ab, then h is equal to b minus a, and the interpolating polynomial of degree 0 is p naught of x is equal to fk. Now in this case, we obtain the rectangular integration rule given by I r of f is equal to integral a to b fk dx, that is approximate to h into fk. Now with this, the error in the integration rule is obtained by equation 13 e r of f is less than or equal to h squared m1 by 2, where m1 equal to maximum of a less than x less than b modulus f dash of x. If the given tabulated value in the interval ab is the value at the midpoint, then we have xk equal to a plus b by 2. And the interval எடுத்துக்கணும். fk வந்து fk plus half. In this case, h வந்து in the length of the interval வந்து b minus a. And we obtain the integration rule as im of f is equal to integral a to b fk plus half into dx, that is approximate to h into fk plus half. Now rule 21 is called the midpoint rule. The rule பேர் என்ன, midpoint rule. The error in the rule calculated from em of f is equal to h squared by 2 integral 0 to half s into ds. This value will be equivalent to 0. H squared by 2 integral of minus half to plus half s into ds, that is equal to 0. This shows that the midpoint rule integrates the polynomial of degree 1 exactly. Hence, the error of the midpoint rule. ஒரு once வந்து நம்ம கொடுத்திருக்க இன்டெகிரலுக்கு சொல்யூஷன் கண்டுபிடிச்ச உடனே நம்ம என்ன கால்குலேட் பண்ணணும், அதோட எரரும் நம்ம கால்குலேட் பண்ணணும். So the corresponding error in the midpoint rule is given by em of f is less than or equal to h cube m2 divided by 2 integral minus half to half s into s minus 1 into ds. So இந்த calculation போட்டோன்னா என்ன கிடைக்கும்னா h cube ml2 divided by 24 where m2 equal to maximum of a less than x less than b modulus f double dash of x and h is equal to b minus a. Now we illustrate these method through an example. Methods first explain பண்ணிட்டோம். இப்போ மெத்தடை யூஸ் பண்ணி ப்ராப்ளம் எப்படி சால்வ் பண்ணுறதுன்னு பார்க்க போகிறோம். இப்போ இந்த ப்ராப்ளம் என்ன கொடுத்துருக்குன்னா எக்ஸாம்பிள் டு எவாலுவேட் integral 0 to 1 e power minus x square dx using என்னென்ன ரூலில் rectangular rule, midpoint rule, trapezoidal rule, Simpson's rule. If the exact value of the integral வந்து 0.74682 correct to 5 decimal places, find the error in this rule. எந்த ரூலுக்கு நமக்கு எக்ஸாக்ட் வேல்யூ 0.74682 கிடைக்குதோ அந்த ரூலுக்கு மட்டும் நம்ம என்ன கால்குலேட் பண்ண போகிறோம், எரர் வந்து நம்ம கால்குலேட் பண்ண போகிறோம். இப்போ ஒவ்வொரு மெத்தடாக இதை கால்குலேட் பண்ணியிருக்கோம். பாருங்க, the values of the function f of x is equal to e power minus x square at x is equal to 0, 0.5 and 1. இப்போ ஏன்னா இன்டர்வல் வந்து நம்ம என்ன கொடுத்துருக்கா 0 to 1 கொடுத்துருக்கா. இப்போ இது ரெண்டாக ஸ்ப்ளிட் பண்ணிக்கிறோம். 0 to 0.5, இன்னொன்று வந்து 0.5 to 1. And f of 0 equal to 1, f of 0.5 equal to 0. அந்த e பவரில் போடணும். e பவர் வந்து நமக்கு ஒரு டேபிள் இருக்கும், அல்லது யூ ஹாவ் டு டேக் லாக் ஆன் போத் சைட். அந்த லாக் புக்கை வச்சு நம்ம கண்டுபிடிச்சு அதுக்கு ஆன்டி லாக் போடணும். ஸோ எக்ஸ் வந்து 0.05 and 1 ஆர் எஃப் ஆஃப் 0 ஈக்குவல் டு 1 அண்ட் எஃப் ஆஃப் 0.5 ஈக்குவல் டு 0.7788 அண்ட் எஃப் ஆஃப் 1ஓட வேல்யூ என்ன கிடைக்குது 0.36788. இப்போ வந்து டேக்கிங் ஹச் இஸ் ஈக்குவல் டு 1. நவ் யூசிங் ஃபர்ஸ்ட் மெத்தட் என்ன கொடுத்துருக்கு, ரெக்டாங்குலர் ரூல். ரெக்டாங்குலர் ரூலில் வந்து ஐஆர் ஆஃப் எஃப் இஸ் ஈக்குவல் டு ஹச் இன்டு எஃப் நாட் அண்ட் ஐஆர் ஆஃப் எஃப் இஸ் ஈக்குவல் டு 1. அடுத்தது செகண்ட் ரூல் வந்து என்ன கொடுத்துருக்காங்கன்னா மிட் பாயிண்ட் ரூல். மிட் பாயிண்ட் ரூலில் வந்து ஐஎம் ஆஃப் எஃப் இஸ் ஈக்குவல் டு ஹச் இன்டு எஃப் 1/2. ஹியர் ஆல்சோ வி கெட் ஐஎம் ஆஃப் எஃப் இஸ் ஈக்குவல் டு 0.7788 and IT of f. IT of f is a trapezoidal rule. Trapezoidal rule is IT of f is equal to h/2 into f naught plus f1. That is, we get IT of f is equal to h/2. H will be 1/2 into f naught plus f1. And that panning taking h is equal to 0.5. Now using Simpson's rule, we get in the IS of f under the Simpson's rule, IT of f under the trapezoidal rule, IM of f under the midpoint rule, IR of f under the rectangular rule. So the Simpson's rule என்ன கிடைக்குதுன்னு பார்ப்போம். IS of f is equal to h/3 into f naught plus 4f1 plus f2. That is equal to h/3 into f of 0 plus 4 into f of 0.5 plus f of 1. That is equal to 0.74718. So exact value of the integral is 0.74682. So error in this rule is given by ER of f is equal to minus 0.25318 and EM of f is equal to minus 0.03198. So இப்போ வந்து மெத்தட் யூசிங் நியூட்டன்ஸ் ஃபார்வர்ட் இன்டர்போலேஷன். ஸோ இந்த ப்ராப்ளத்தில் வந்து கொடுத்துருக்க ஒரே ஒரு ப்ராப்ளத்துக்கு நம்ம ரெக்டாங்குலர் ரூல், மிட் பாயிண்ட் ரூல், ட்ரெபசாய்டல் ரூல், சிம்சன்ஸ் ரூல், எந்த இதுக்கு எக்ஸாக்ட் வேல்யூ 0.74682 கிடைக்குதோ 74682 எக்ஸாக்ட் வேல்யூ வந்து எது கிடைக்குது, சிம்சன்ஸ் ரூலில் தான் கிடைக்குது. ஏன்னா 0.74718, this is approximate to 0.74682. So the corresponding error in ER of f is equal to minus 0.25318 and in the midpoint rule EM of f is equal to minus 0.03198. Now next method using Newton's forward interpolation. Now let the data be given equispaced nodal point. அது equivalent space இருக்கும் அந்த interval எல்லாம். அப்போ that is xk equal to x naught plus sh, s is equal to 0 to n, where x naught equal to a and xn equal to x naught plus nh, that is equal to b. ஏன்னா b வந்து எப்படி மார்க் பண்றோம்னு பாருங்க, x naught plus nh அப்படின்னு என்ன அர்த்தம்னா ஸ்டார்டிங் இன்டர்வலோட அந்த எண்டிங் இன்டர்வல் வந்து ஸ்லைட் வேரியேஷன். ஏன்னா அந்த ஈக்குவல் ஸ்பேஸ் இன்டர்வல் ஹச் இருக்குல்ல, அந்த ஹச்சை வந்து என்னால மல்டிப்ளை பண்றேன், xn வந்து x naught plus nh, that is equal to b. ஸ்டெப் லென்த் இங்க என்ன இருக்கும், h is equal to b minus a by n. So the Newton's forward finite difference interpolation formula, interpolating this data is given by f of x is equal to Pn of x, that is equal to f naught plus s into del f naught plus s into s minus 1 into del square f naught by 2 plus etc. The last term has s into s minus 1, s minus 2, etc. s minus n plus 1 into del power n f naught divided by n factorial. With the error of interpolation, en plus 1 of f is equal to h power n minus 1, s into s minus 1, s minus 2, etc., s minus n divided by n plus 1 factorial f power n plus 1 of alpha. Now integrating both sides with respect to x between the limit a and b, we can approximate the definite integral I by the numerical integration rule, that is I h of f is equal to integral a to b pn of x dx, that is equal to h into integral 0 to 1 f naught plus s into del f naught plus s into s minus 1 by 2 into del square f naught plus etc. into ds. Now the error interpolation for the above the I h of f is given by, what is the error? The error is modulus of E h of f, which is less than or equal to h power n plus 2 m n plus 1 divided by n plus 1 factorial integral 0 to 1 s into s minus 1 etc. s minus n into ds. Now we can obtain the trapezoidal rule 14 from 24 by using the linear interpolation. F of x is equal to approximate to p n p1 of x, that is equal to f naught plus s into del f naught. We then have int of f is equal to h into integral 0 to 1 f naught plus s into del f naught into ds, that is equal to h into s f naught plus s squared by 2 del f naught, that is equal to h into f naught plus del f naught by 2, that is equal to h by 2 into f naught plus f1 with the error of integration given by 15. Now similarly Simpson's rule 16 can be obtained from 24 by using quadratic interpolation. F of x approximate to p2 of x, taking x naught equal to a, x1 equal to x naught plus h, and x2 equal to x naught plus 2h, that is equal to b. We have is of f is equal to integral a to b f of x dx, that is equal to h into integral 0 to 2. ஏன்னா இன்டர்வல் நமக்கு என்ன கொடுத்துருக்கோம் 0 to 2, f of x பதிலாக நம்ம ரீப்ளேஸ் பண்ணுறோம் f naught plus s into del f naught plus s into s minus 1 by 2 into del square f naught into ds, that is equal to, after integrating the value become h into first term என்ன ஆகும் 2f naught plus 2 into del f naught plus del square f naught by 3. ஏன்னா அந்த இன்டகிரேட் பண்ணி நம்ம லிமிட் அப்ளை பண்ணும்போது நமக்கு இந்த ஆன்சர் கிடைக்கும், that is equal to h by 3 into f naught plus 4f1 plus f2. So the error of this will be the error. அப்போ ஃபர்ஸ்ட் வந்து கொடுத்துருக்க ஃபங்க்ஷனுக்கு மெத்தடை யூஸ் பண்ணி சொல்யூஷன் கண்டுபிடிச்சோம், அதுக்கப்புறம் அந்த மெத்தடுக்கு நம்ம என்ன கண்டுபிடிக்கணும், எரர் கால்குலேட் பண்ணணும். To find the approximate value of I equal to integral 0 to 1 dx by 1 plus x using Simpson's rule. Obtain the error bound and compare it with the actual error. Also compare the result obtained here with one obtained in example 1ல என்ன obtain பண்ணிருக்கோமோ அதையும் நம்ம கம்பேர் பண்ணணும். ஏன்னா எக்ஸாம்பிள் 1 வந்து நமக்கு என்ன கொடுத்துருக்காங்கன்னா இந்த ப்ராப்ளம் தான் நம்ம டீல் பண்ணியிருக்கோம். எக்ஸாம்பிள் 1, what is that example 1? This see here, find the approximate value of I equal to integral 0 to 1 dx by 1 plus x using trapezoidal rule and obtain a bound for the error. The exact value வந்து என்ன கண்டுபிடிச்சா அதை கரெக்ட் பண்ணுறோமா. ஸோ இதே ப்ராப்ளத்துக்கு நம்ம இங்கே வந்து எக்ஸாம்பிள் 3ல நம்ம என்ன பார்க்க போகிறோம்னா, see here, find the approximate value using the Simpson's rule. Here x naught 0, x1 வந்து 0.5, x2 வந்து 1, h வந்து half. Now using Simpson's rule we have is of f, அந்த ஃபார்முலாவில் கொண்டு வந்து சப்ஸ்டியூட் பண்ணுறோம். சப்ஸ்டியூட் பண்ணால் என்ன கிடைக்குது, 0.694445. Now exact value of I வந்து equal to log 2. Log 2ஓட வேல்யூ வந்து 0.693147. So actual error வந்து 0.001297. The bound for the error is given by modulus ES of f is less than or equal to h power 5 by 90 into m4, that is equal to 0.00833, where m4 equal to maximum of modulus 24 by bracket வந்து 1 plus x the whole power 5, that is equal to 24. Here 2, the actual error is less than the given bound. Also actual obtained here is much less than that of the example 1. இப்போ இந்த மாதிரி find approximation of integral, இங்கே ab என்ன கொடுத்துருக்கா, a வந்து 1.1, b வந்து 1.5, நம்ம கொடுத்துருக்க ஃபங்க்ஷன் வந்து e power x, trapezoidal rule and the equal space of interval h வந்து என்ன இருக்கு 0.4, Simpson's rule வந்து h வந்து 0.2. Now composite integration. In composite integration, we derive the given interval AB into a number of sub-intervals and evaluate the integral each of the sub-interval using one of the integration rule. Now we shall, what are the integration rule? நமக்கு என்னென்ன இருக்கு, நமக்கு வந்து trapezoidal rule, Simpson's rule, midpoint rule, and then that is Ranchikutta rule. So all those rules are available here. And evaluate the integral each of the sub-interval using one of the integration rule. ஏதாவது ஒரு integration rule வச்சு நம்ம evaluate பண்ண சொல்றோம். So we shall construct composite rule of integration for trapezoidal Simpson method and find the corresponding error of integration when these composite rules are used. இப்போ நம்ம என்ன பண்ண போறோம்னா, the composite rule for integration எது ரெண்டுக்கு யூஸ் பண்ண போறோம்னா, trapezoidal and Simpson's method. And also find the corresponding error. Corresponding error நம்ம calculate பண்றோம். இப்போ composite trapezoidal rule. We divide the interval AB into n subinterval of length h is equal to b minus a by n. We denote the subinterval xk minus 1 xk, k equal to 1 to n, where x naught equal to a, xn equal to b. Then I equal to integral a to b f of x dx, that is equal to sigma k equal to 1 to n integral of xk minus 1 xk f of x dx. Now evaluating each of the integral on the right hand side of the trapezoidal rule. Trapezoidal rule உள்ள right hand side உள்ள ஒவ்வொரு integral என்ன செய்யணும், integrate பண்ணா we have evaluating each of the integral on the right hand side of the trapezoidal rule. We have it of f is equal to sigma k equal to 1 to n h by 2 into fk minus 1 plus fk, that is equal to h by 2 into f naught plus fn plus 2 into f1 plus f2 plus etc plus fn minus 1. The method is known as, in the method this is the required formula to find the integral values of the composite trapezoidal rule. That is it of f is equal to h by 2 into f naught plus f1 starting point ending function plus 2 times the remaining value, 2 into f1 plus f2 plus etc plus fn minus 1. Now the error value, corresponding error value calculate பண்ணோம்ல, அது என்னது, et of f is equal to minus h cube by 12 sigma I is equal to 1 to n f double dash of alpha I, where alpha எந்த ரெண்டு இன்டர்வலுக்கு நடுவுல லையா இருக்கு, xk minus 1 and xk, k வந்து 1 to n. Now since f is a continuous function on the interval ab, we have as a consequence of intermediate value theorem sigma I is equal to 1 to n f double dash of alpha I equal to f double dash of zeta sigma I is equal to 1 to n 1, where a வந்து a is less than zeta less than b. இந்த zeta-ஓட interval வந்து lies between a and b. அப்போ et of f I equal to minus h cube by 12 f double dash of zeta into n, and a is less than zeta less than b, that is equal to minus nh by 12 h square f double dash of zeta, that is equal to minus of b minus a into h square divided by 12 f double dash of zeta. Now if m2 equal to maximum a less than zeta less than b modulus f double dash of zeta, then modulus et of f is less than or equal to b minus a into h square divided by 2 into m2. The error is of order h square and decreases the h as h decreases. The composite trapezoidal rule integrate exactly polynomial of degree less than or equal to 1. We can try to remember the formula for 26. What is the 26 formula? The formula தான் நம்ம மைண்ட்ல மெமரியில் ஏற்றிக்கணும். That is it of f is equal to h by 2 into h என்றது equal space, h by 2 into starting function f naught plus fn plus twice f1 plus f2 plus etc up to எது வரைக்கும் எழுதணும், fn minus 1. ஏன்னா fn முன்னாடி கொடுத்துட்டோம், f naught கொடுத்துட்டோம். So this method is called a composite trapezoidal rule. Now next the error of the order h square decreases as h decreases. Composite trapezoidal rule integrate exactly polynomial of degree less than or equal to 1. We can try to remember the formula it of f is equal to h by 2 into first ordinate plus last ordinate plus 2 into sum of the remaining ordinates. So easily you can remember this formula as the composite of the function, composite trapezoidal rule of the function it of f is equal to h by 2 into open a bracket first ordinate plus last ordinate plus twice the sum of the remaining ordinate. Now in using Simpson's rule of integration, we need 3 abscissors, and so we divide the interval AB into an even number of subinterval of equal length, giving an odd number of abscissors in the form that is A equal to x naught less than etc less than x to n, that is equal to b with h is equal to b minus a by 2n, and xk equal to x naught plus kh, k equal to 0 1 to etc to n. Then we write I equal to integral a to b f of x dx, that is equal to sigma k equal to 1 to n integral of x2k minus 2 x2k f of x dx. Now we are evaluating each of these interval on the right hand side of the equation 28 by the rule use பண்ண போறோம், Simpson's rule. That is it of f is equal to sigma k equal to 1 to n h by 3 into f2k minus 2 plus 4 into f2k minus 1 plus f2k. That is equal to h by 3 into f0 plus f2n plus 4 into the sum of the odd ordinate plus twice sum of the even ordinate. That is the first ordinate plus even ordinate plus 4 into sum of the odd ordinate plus twice the sum of the even ordinate. The formula is known as composite Simpson's rule of numerical integration. இப்போ இந்த ஃபார்முலாவை நம்ம மெமரியில் நல்லா வச்சுக்கணும். இது எப்படி நம்ம மைண்டில் வந்து ஈஸியாக மெமரியில் வச்சுக்கணும்னா h/3 இன்ட்டு த ஃபர்ஸ்ட் ஆர்டினேட் ப்ளஸ் ஈவன் nth ஆர்டினேட் ப்ளஸ் 4 இன்ட்டு சம் ஆஃப் த ஆட் ஆர்டினேட் ப்ளஸ் 2 இன்ட்டு சம் ஆஃப் த ஈவன் ordinate. This error 29 is obtained from 18 by adding up the errors. Hence, we get the formula is known as composite Simpson's rule of numerical integration, and the corresponding error is obtained by adding up all the errors. எல்லா errors ஆட் பண்ணோம்னா நமக்கு இது corresponding உள்ள error வந்து நமக்கு கிடைச்சிரும். That is ES of F is equal to minus h power 5 by 90 sigma k equal to 1 to n f fourth derivative of alpha k x2k minus 2 less than alpha k less than x2k. That is equal to minus h power 5 by 90 f fourth derivative of zeta sigma is equal to 1 to n 1 where a is less than zeta less than b. That is equal to minus n into h power 5 by 90 f power fourth derivative of zeta. That is equal to minus of b minus a into h power 4 by 180 f fourth derivative of zeta. Now if m4 equal to maximum of modulus this, we can write using h order value b minus a by 2n. So modulus es of f is equal to less than or equal to b minus a by 180 h power 4 into m power 4. That is equal to b minus a whole power 5 into m power 4 m4 divided by 2880 n power 4. The error is of order h power 4 and it approaches 0 very last as h tends to 0. The rule integrate exactly polynomial of degree less than or equal to 3. We can remember the composite Simpson. That ரொம்ப ரொம்ப important. எப்படி அந்த ஃபார்முலாவை நம்ம ஈஸியாக ரிமெம்பர் பண்ணிக்கணும். That is composite Simpson's rule. IS of f is equal to h by 3 into first ordinate plus last ordinate twice the sum of even ordinate 4 times sum of the remaining odd ordinate. Now illustrate the composite rule, trapezoidal and Simpson's rule through an example. Here I evaluate integral 0 to 1 dx by 1 plus s using composite trapezoidal rule, composite Simpson's rule with 2, 4 and 8 or subinterval. Already in the integral மற்ற மெத்தட் யூஸ் பண்ணிருக்கோம். Same integral along with the same integrate function. You have to using the several methods, namely composite trapezoidal rule, composite Simpson's rule with 2, 4 and 8 are the subinterval. Solution. We give in table 1 the values of f of x with h is equal to 1 by 8 from x equal to 0 to x equal to 1. That is our table frame பண்ணிருக்கோமா. இன்டர்வல் வந்து 0 to 1 0 to 1க்கு நம்ம சப் இன்டர்வல் வந்து நம்மளா சூஸ் பண்ணிக்கிறோம். 1 by 8, 2 by 8, 3 by 8, 4 by 8 etc. அப்போ கரஸ்பாண்டிங் f of x என்ன கிடைக்கும் அதில் சப்ஸ்டிட் பண்ணி வரணும். ஏன்னா f of x equal to 1 by 1 plus 6. அப்போ எஃப்க்கு வந்து f of 0ன்னு போட்டிங்கன்னா 1 by 1 plus 0 அப்போ 1 ஆயிரும். அடுத்து 1 by 8 1 by 8 என்ன ஆகும் 1 by 1 plus 1 by 8 that is equal to 9 by 8 by 9. இதே மாதிரி எல்லாத்துக்கும் கண்டுபிடிச்சிட்டோம்னா n equal to 2 then h is equal to 0.5 and the ordinates f0 f1 and f8 ought to be used. IT of f that is trapezoidal rule 1 by 4 into f0 plus 2 f4 plus f8 எல்லா வேல்யூ சப்ஸ்டிட் பண்ணீங்கன்னா your answer is this. And then Simpson's rule IS of f is equal to 1 by 6 into f0 plus 4 f1 plus f8. அதனுடைய வேல்யூ என்ன கிடைக்குது நமக்கு 0.69444 கிடைக்குது. So if n equal to 4 then h is equal to 0.25 and the ordinates என்ன எடுத்துக்கிறோம் f0 f2 f4 f6 and f8 ought to be used. So the trapezoidal IT of f is equal to 1 by 8 into f0 plus that is first ordinate and last ordinate and twice the and that is even ordinate f0 plus f8 plus 2 into f2 plus f4 plus f6 எல்லா வேல்யூ சப்ஸ்டிட் பண்ணி கால்குலேட் பண்ணிடும். அடுத்து IS of f that is equal to 1 by 12 into f0 plus f8 plus 4 times f2 plus f6 plus 2 times f4. அது என்ன வேல்யூ n equal to 8 n 8 இருக்கும்போது h ஓட வேல்யூ என்ன 1 by 8 and all the ordinates in table 1 are to be used. So we are going to calculate the value for IS of f and then if n equal to 8 h is equal to 1 by 8 IT of f ன்றது trapezoidal rule IS of f ன்றது என்ன Simpson's rule. Trapezoidal rule வந்து 1 by h into that is 1 by 16 into that is f0 plus first ordinate last ordinate twice the sum of the remaining ordinate. Simpson's rule என்ன ஃபார்முலா வருது 1 by 24 into f0 plus first ordinate last ordinate plus 4 times odd ordinate plus 2 times the remaining even ordinate. So the exact value of the given integral correct to 6 decimal places is log 2, that is equal to 0.693147. Now we now give the actual error in table 2 below, that is ET of F. 2க்கு என்ன எரர் வரும், அது 2க்கு error regarding trapezoidal rule, 2க்கு error regarding Simpson's rule, அதே மாதிரி 4 and then 8. So as the note that H decreases the error, the both trapezoidal Simpson's rule also decreases. H வந்து decrease ஆகும்போது நம்ம இங்க ரெண்டு ரூல் யூஸ் பண்ணி கால்குலேட் பண்றோம். ஒன்று வந்து trapezoidal rule, இன்னொன்று என்னது Simpson's rule. ஸோ அந்த ரெண்டு ரூல்லையுமே அந்த வேல்யூ வந்து என்ன ஆயிடுது, டிக்ரீஸ் ஆயிடுது. Now example 5. Find the minimum number of intervals care to evaluate integral 0 to 1 dx by 1 plus x with an accuracy 10 to the power of minus 6 by using Simpson's rule. Now in example 4, we may observe from table 2 that n is approximately 8 gives 10 to the power of minus 6, 1 point e minus 0.6 accuracy. We shall now determine n from the theoretical error bound for Simpson's rule, which gives 1 point e minus 0.6 accuracy. Now modulus es of f is less than or equal to b minus a the whole power 5 m4 divided by 2880 n power 4. So m4 is equal to maximum of 0 less than x less than 1 modulus f fourth derivative of x. Now the maximum 0 less than x less than 1, f fourth derivative of x is equal to 24 by 1 plus x the whole power 5, that is equal to 24. Now to obtain the required accuracy, we should therefore have 24 by 2880 n power 4 less than or equal to 10 to the power of minus 6, or n power 4 is greater than or equal to this value, that is equal to 8,333.333. Now n is, so in the value நம்ம approximate என்ன கண்டுபிடிக்கிறோம்னா n is greater than or equal to 9.5. I find that we cannot take n equal to 9, since to make use of Simpson's rule, we should have even number of interval. We therefore conclude that n equal to 10 should be the minimum number of subinterval to obtain an accuracy, that is 1 point e minus 0.6, that is 10 to the power of minus 6. Now Romberg integration. In Romberg integration, first we find the power. இதுக்கு முன்னாடி என்ன பார்த்தோம், trapezoidal, Simpsons, and then midpoint, and all those things, the formulas, the corresponding error, and then for one single example, we have to use all those methods. So here we have come to the last method as the Romberg integration. In Romberg integration, first we find the power series expansion of the error term in the integration method. Then by eliminating the leading term in the error expression, we obtain a new values which are higher order than the previously computed values. Now, if f naught of h denote the approximate value obtained by using the composite trapezoidal rule. Composite trapezoidal already introduce பண்ணிட்டோம். So I is equal to f naught of h plus c1 h square plus c2 h power 4 plus c3 h power 6 plus etc., where I is the exact value of the integral. Let the integral be evaluated the step length. The step length என்ன எடுத்துக்கிறோம், h by 2 and h power 4. Then I is equal to f naught of h plus c1 h square plus c2 h power 4. Now I is equal to, then eliminating c1 from the equation 31 and 32, and the I eliminate c1 eliminate பண்ணோம்னா this is 31 c1, and then 32 will be f naught into, and the same thing, f naught h c1 h squared, c1 by 4 h squared plus c2 by 16 h power 4 plus etc. இந்த ரெண்டு f iல இருந்தோம், நம்ம எதை எலிமினேட் பண்ண போறோம், c1 எலிமினேட் பண்ணோம். அப்ப I is approximate to 1 by 3 into 3 f naught h by 2 minus f naught of h, that is equal to f1 of h. So note that the values of 0 are h power 4. Similarly, I is approximate to 1 by 3 into open a bracket 4 f naught h by 4 minus f naught into h by 2, that is equal to f1 of h by 2. Applying this method repeatedly by eliminating c2 and c3. First c1 eliminate பண்றோம், அடுத்து இதே மெத்தடை ரிப்பீட்டடா யூஸ் பண்ணி எதாவது எலிமினேட் பண்ண போறோம், c2 eliminate பண்றோம், c3 eliminate பண்றோம். So we get the Romberg integration formula. This is the main formula regarding Romberg. Fm of h is equal to 4 power m fm minus 1 of h by 2 minus fm minus 1 of h divided by 4 power m minus 1 m equal to 1 to etc. Now in the same way, g naught of h denote the value of the integral obtained by using the Simpson's rule. Then I is equal to g naught of h plus d1 h power 4 plus d2 h power 6 plus d3 h power 8 plus etc. Now the Simpson's rule, then I is equal to g naught of h the plus d1 h power 4 plus d2 h power 6 plus d3 h power 8, where I is the exact value of the integral. Now the integral be evaluated by using the step length. என்னென்ன step length எடுத்துக்கிறோம், h is equal to h by 2 and h by 4. Then we have I is equal to g naught of h plus d1 h power 4 d2 h power 6 at I. Eliminating d1 from these two equations, upper approximation is d1 of h. Similarly, eliminating d2, upper approximation is g1 of h by 2. Now, example 6. Find the value of the integral. Again, using the same example, composite trapezoidal, composite Simpson, 3, 5th, and 9 nodes. Using extrapolation technique to improve the result. We take the computer value, for example, 4, and the 4 and the computer value. The Romberg integration values given in table 3 and 4 for composite trapezoidal and composite Simpson's rule respectively. Now, table 3. N என்ன value எடுத்துக்கோம் பாருங்க 2, 4, 8. Corresponding h oda value na 1 by 2, 1 by 4, 1 by 8. IT of f, trapezoidal rule. F0 of h 0.73 and F1 of h, F2 of h. Note that F1 of 1 by 2 equal to 4 into F0 into 1 by 4 minus F0 of 1 by 2 divided by 3. F1 of 1 by 4 equal to 4 into F0 into 1 by 8 minus F0 into 1 by 4 divided by 3. And F2 of 1 by 2 equal to 16 F1 1 by 4 minus F1 of 1 by 2 divided by 15. இப்போ அடுத்து டேபிள் 4 இங்கே என்ன எடுத்துக்கிறோம் n equal to இப்போ இதில் வந்து ஹச்சுக்கு அகெயின் சேம் வேல்யூ ஐஎஸ் சிம்சன்ஸ் ரூல் ஃபர்ஸ்ட் டேபிள் வந்து ரிகார்டிங் ட்ரெபிசாய்டல் ரூல் ஐடி ஆஃப் எஃப் செகண்ட் ரூல் வந்து ஐஎஸ் ஆஃப் எஃப் ஜி நாட் ஆஃப் ஹெச் அந்த வேல்யூஸ் கண்டுபிடிச்சோன்னா G1 G2 எல்லாம் கால்குலேட் பண்ணிடும். ஸோ பை யூசிங் திஸ் G1 of 1 by 2 ஓட வேல்யூ G1 of 1 by 4 again you have to use G2 of 1 by 2. Suppose that you wish to evaluate the integral in the above example directly by the trapezoidal and Simpson's rule to an accuracy 1.0 e minus 0.6. What should be the maximum value of step length to be chosen to achieve this accuracy? The maximum, to answer this question, let us illustrate the error bound of trapezoidal rule. The error bound will be modulus ET of f is greater than h square by 48. Therefore, h square by 48 is less than 1.e minus 0.6. Therefore, h is approximate to 0.07, n is approximate to 145. Thus, to obtain 1.e minus 0.6 accuracy by trapezoidal rule, we need to use 145 subinterval, that is 146 function evaluation. But by extrapolation, we have used only 9 evaluation to improve this result. I'm using composite trapezoidal rule to find integral 1 to 2.2 log x dx when n equal to 3, 6 and 12. If n is 3, 6, 12, what is the corresponding interval? H is equal to 0.4, 0.2, 0.1. If a trapezoidal rule, IT of f is equal to f naught of y, that is equal to 0.527395 and then 0.534591 and 0.534152 and the corresponding f1 of h and f2 of h, that is 0.534605 and 0.534591 and then f2 of h is equal to 0.534606. Now using in this unit we learned the following. What are the outcome we learned through this unit as if a function f of x is not known explicitly but a table of values of x is given, or when it has no antiderivative expressible in terms of elementary function, then its integral cannot be obtained by calculus method. In such cases, numerical integration methods are used to find the definite integral of f of x. Now, second one, the basic idea of numerical integration method is to approximate the definite integral as a linear combination of the values of f of x in the form integral a to b f of x dx approximate to sigma k equal to 0 to n beta k f of x k, where the n plus 1 distinct nodes. இந்த n plus 1 distinct nodes எப்படி கிடைக்குதுன்னா கொடுத்துருக்க இன்டர்வலை ஏபியை வந்து நம்ம n plus 1 பார்ட்டிஷனை மாற்றுறோம். அதான் பார்ட்டிஷன் என்னென்ன இருக்குன்னா x0 less than x1, etc. less than xn. Divide the integral ab into n subinterval with the weight when the beta k equal to 0 to n or the weight of the integration rule. The error of the integration method is this given by modulus e h of f is equal to integral a to b f of x dx minus sigma k equal to 0 to n beta k f of x k. And then for eq space to nodes, the integration formulas derived by using Lagrange interpolating polynomial Pn of x of degree less than or equal to n, satisfying the interpolatory condition Pn of xk, that is equal to f of xk, k equal to 0 to n are known as Newton-Cotes formulas. Corresponding to n equal to 1, n equal to 2, Newton-Cotes formula, trapezoidal rule, Simpson's rules are obtained. For large integration interval, Newton-Cotes formulas are generally unsuitable for the given large error. Large error கொடுக்கிறதுனால Newton-Cotes வந்து suitable இல்லைன்னா. Composite integration method can be used in such cases by dividing the interval into a large number of sub-intervals and evaluating the integral each of the sub-interval using one of the integration rule. For improving the accuracy of the trapezoidal rule or Simpson's rule and to obtain the higher order solution, Romberg integration can be used. That is now in the 14th section, numerical solution of ordinary differential equation. That is introduction, objective, basic concept, Taylor series method, Euler's method, Richardson extrapolation, and then summary, some exercise problem solution and answers. After reading this unit, the 14th unit, after reading this unit, we should be able to identify the initial value problem for the first order ordinary differential equation, obtain the solution of the initial value problem by using the Taylor series method or Euler's method, and then use Richardson extrapolation technique for improving the accuracy of the result obtained by Euler's method. Basic concept. In this section, we shall state a few definitions from the theory of differential equation, define some concept involved in the numerical solution of differential equation. Definition. All equation involving one or more unknown function, dependent variable and its derivative with respect to one or more known function. For example, the independent variable is called a differential equation. Differential equation example on the x into dy by dx equal to 2y. Now, x into dz by dx plus y into dz by dy minus z equal to 0 are also differential equation. Differential equation of the form 1 involving derivatives with respect to a single independent variable are called ordinary differential equation. Here, this example in the equation 2, it depends involving the derivative involving the two or more independent variables. So, very important. This is the initial introduction regarding ordinary differential equation and partial differential equation. Ordinary differential equation derivative involve only the single independent variable, and the partial differential equation, the derivative involving the two independent variable. Definition. The order of the order degree தான் initial நம்ம differential equation introduce பண்றோம். The order of a differential equation is the order of the highest order derivative appearing in the equation, and its degree is the highest exponent of the highest order derivative after the equation has been rationalized. And that's rationalized ரொம்ப important. After it has been expressed in the form of free from radical and any fractional power of the derivative or negative power, for an example, the equation d cube by y by dx cube the whole square plus 2 into d square by dx square minus dy by dx plus x square into dx by dx, and that is the whole cube, that is equal to 0 is of third order and is second degree. Second, the highest derivative என்ன இருக்கு d cube y by dx cube. அந்த ஹையஸ்ட் டெரிவேட்டிவ் பவர் என்ன இருக்கு 2 இருக்கா, அப்போ அந்த ஹையஸ்ட் டெரிவேட்டிவ் தான் நமக்கு ஆர்டர், தட் இஸ் தேர்ட் ஆர்டர். அந்த ஹையஸ்ட் டெரிவேட்டிவ்க்கு ஒரு பவர் இருக்குல்ல, அது வந்து டிகிரி, தட் இஸ் செகண்ட் டிகிரி. நம்ம ஈக்குவேஷன் y ஈக்குவல் டு எக்ஸ் இன்டு டிஒய் பை டிஎக்ஸ் பிளஸ் ஏ இன்டு டிஒய் பை டிஎக்ஸ் இஸ் அ ஃபர்ஸ்ட் ஆர்டர் அண்ட் செகண்ட் டிகிரி. ஃபர்ஸ்ட் இதை வந்து இந்த டினாமினேட்டர் எல்சி எடுத்து எல்லாத்தையும் எலிமினேட் பண்ணி you have to this equation is free from radical, that is, and any fractional power. See here, dy by dx, bring in the numerator minus 1, dy by dx the whole power minus 1. We have to eliminate our fractional power and the derivative or negative power. So, eliminate பண்ணதுக்கு அப்புறம் தான் அந்த ஈக்குவேஷனோட ஆர்டர் டிகிரியை நம்ம வந்து ஐடென்டிஃபை பண்ண முடியும். That's very important. And when the dependent variable and its derivative occur in the first degree only, not as a higher power or product, the equation is said to be linear, otherwise it is non-linear. Linear இருக்கணும், அதாவது ஆர்டர் வந்து ஒன்றா இருந்தால் அது வந்து லீனியர். Now, equation d square by dx square plus y equal to x square is a linear ordinary differential equation where x plus y the whole square into dy by dx equal to 1 is a non-linear ordinary differential equation. This is a linear d square by dx square plus y equal to x square is a linear ordinary differential equation, and this is a non-linear. Similarly, dou square z by dou x square plus dou square z by dou y square minus dou square z by dou x dou y equal to 0 is a non-linear partial differential equation. ஏன்னா மோர் தென் ஒன் டெரிவேட்டிவ்ல வந்து அந்த இண்டிபெண்டன்ட் வேரியபிள் ஒன்னை விட அதிகமாக இருந்தால் அது வந்து partial differential equation. Now in this unit we shall be concerned only with the ordinary differential equation. The general form of a linear ordinary differential equation of order n can be expressed in the form L of y equal to a naught of t y power n. Y power n என்றது வந்து அந்த nth derivative plus a 1 of t y power n minus 1 of t n minus 1th derivative plus etc. plus a n of t y of t, that is equal to r of t. Now where r of t is an operator, general non-linear ordinary differential equation of order n can be written as capital F of t y dash etc. y power n equal to 0. So y power n equal to f of this value. Equation 7 is called canonical representation of equation 6. In such a form, the highest order derivative is expressed in terms of a lower order derivative and the independent variable. The general solution of the nth order ordinary differential equation contains n ordinary constants. In order to determine these arbitrary constants, we require n conditions. If these conditions are given at one point, then these conditions are known as initial condition, and the differential equation together with the initial condition is called an initial value problem. The nth order initial value problem can be written as this yn of t equal to f of t y dash y double dash etc. y power n minus 1. And then yp of t naught value in the y naught of p. Right? So if the nth conditions are prescribed, then one point, then these conditions are known as boundary condition. The differential equation together with the boundary condition is known as boundary value problem. Very important. Next one, the nth order, the initial value problem is equivalent to the following system of n first order equation. Y equal to y1, y dash is equal to y1 dash, y1 dash and a y2, again y2 dash is equal to y3, etc. So in the vector notation, we are writing this equation as dy by dt equal to f of t comma y and y of t naught equal to alpha, where y equal to y1, y2, etc. yn whole power t, and f of t comma y equal to y1, y2, y3, etc. f of t comma y1, etc. yn the whole transpose. t ன்றது இந்த இடத்துல நமக்கு transpose. இப்போ வந்து நம்ம நெசசரி தியரம் ஒன்று ஃபாலோ பண்ண போகிறோம். f of t comma y satisfies the condition. f of t comma y is a real function defined and continuous for t belongs to the closed interval t naught comma v and y belongs to the open interval minus infinity comma infinity. The third condition, there is a constant L such that for any t belongs to the closed interval t naught comma v and for any two numbers y1 and y2, modulus f of L of y1 minus y2. Then for any y naught, the IVP has a unique solution. Now this condition is called as that is Leibniz condition, and L is called this constant, corresponding constant. Then we assume that existence and uniqueness of the solution also that f of t comma y has continuous partial derivative with respect to t and y is higher order we desire. And we have to introduce the mesh point. We obtain the mesh point or grid point t naught etc. tn. Next one, we have to give then approximate method for numerical method can be obtained by approximating e power lambda h. For example, we make use of the following polynomial approximation e power lambda h that is equal to 1 plus lambda h plus 0 into modulus lambda h squared. And then what is e power x? E power x expansion as 1 plus x squared by 2 factorial plus etc. Here, we are writing e power lambda h only up to the third degree and the remaining degree come in the order of modulus lambda h whole power 4. So therefore, e power lambda h values is 1 plus lambda h plus lambda squared h squared by 2 plus lambda cube h cube by 6 plus the order of this and so on. Now let us retain the p plus 1 term in the expression of e power lambda h and denote the approximation to e power lambda y by capital E of that is expectation of lambda h. The numerical method for obtaining the approximate value yn of y of tn can be written as yn plus 1 is equal to the expectation that is E of lambda h into yn. And n takes a value in 0 to n minus 1. Now the truncation error te of the method is defined by y of tn plus 1 minus yn plus 1. Since p plus 1 terms are retained in the expression of e power lambda h the whole power p plus 1 divided by p plus 1 factorial e power theta into lambda h and 0 is less than t less than 1. Now through this we say that the numerical method is stable and if the error at any stage yn minus y of tn equal to epsilon n remains bounded as n tends to infinity. Now let us examine the stability of the numerical method by using this, and we have to find a local truncation error and putting yn plus 1 equal to y of tn plus 1 plus epsilon n plus 1 and yn equal to y of tn plus epsilon n. In this equation, we arrive the concept of y of tn plus 1 plus epsilon n plus 1 takes the value e of lambda h into y of tn plus epsilon n. And epsilon n plus 1 equal to, so with this I conclude this session. This is the last session for this block. Thank you. Nandri.